Back with day 72 here. Today we're looking at the average value of a function. This is not to be confused with average rate of change of a function. Okay? All we know right now is average rate of change. Average rate of change of f on AB is still f of b minus f of a over b minus a. But now we're working with average value of a function. It's really easy to get those two mixed up. So it's going to be important. I'll ask you questions about both tomorrow just to highlight the difference and how you have to really pay close attention to the difference there. Okay, I'm just going to give you the formula here for average value of a function, and we'll look at an example or two. So here we go. So the average value of a function f on an interval a, b is always equal to 1 over b minus a times the integral from b to a of f of x dx. The cool thing about average value is it just tells you your average y. Now we're used to averaging things that are linear, right? We just add them up and divide by 2 and it's no big deal. But things that aren't linear aren't going to have linear averages. But doing 1 over b minus a times the integral from b to a to b of f of x dx will always give us that. Okay. Hold on one second. I got to... It's the integral from a to b of f of x dx. Okay, so let me show you one example of this without units, and then an example with units so we know what happens with the units. Okay, so if I tell you that f of x equals 6x squared minus 2, I'd say find the average value of f on the interval from 1 to 3. Okay, so we know this is an average value problem because the problem says find the average value of f on 1 to 3. Right? It does not say find the average rate of change. It says find the average value of f on 1 to 3. Okay, so what I want you to do is identify, we have our interval here from 1 to 3. 1 is our a, 3 is our b. So this average value of f is going to equal 1 over b minus a. So that's 3 minus 1 times the integral from 1 to 3 of our function 6x squared minus 2 dx. Okay. Now, if you have a calculator for these problems, you can just type this in right now into our calculator and get the answer, which sometimes you'll have to do. Other times we'll have to figure this out without a calculator. The key on this is that you do not lose track of that 1/2 that's out front. Okay? We do our definite integral the way that we've always done definite integrals, but we just have to keep track of that 1/2 that's out front. So what I want you to get in the habit of is as you're solving this thing down, keep writing that fraction out front over and over and over again so you don't forget it at the very end. So here's what it's going to look like. 1 over 3 minus 1 is just 1/2. Then I'm going to bump and divide. This is just a power rule antiderivative here. I'm going to bump the x up to cubed and divide by 3. 6 divided by 3 is 2. And I'm going to tack on the x here. And again, I should be able to stop and check right now. I didn't write the big S because I did my antiderivative. If I do the derivative of my antiderivative, I should get my original function back. The derivative of 2x cubed minus 2x is 6x squared minus 2. So I know we're good. And again, I'm going to keep writing my 1/2. Okay? Now I'm going to plug in 3, and then plug in 1 and subtract the 2. So I'm going to have 2 times 3 cubed minus 2 times 3 minus 2 times 1 cubed minus 2 times 1. And again, every step that I'm simplifying this, I can't forget about this 1/2. This is what people forget. And they just end up solving the definite integral and they miss points on it. So 3 cubed is 27. 27 times 2 is 54. So I've got 54 minus 6. Over here I've got 2 minus 2. 54 minus 6 is 48. And then 2 minus 2 is 0. So my answer is going to be half of 48, which is equal to 24. Okay. Again, I should be able to type that into my calculator. I should be able to type that original problem into my calculator here. Let's just check it to make sure that it's right. And again, when you do this, just type your fraction in first, then hit math 9 to call it that integral. So again, I'll do 1/2, then I'll do math 9, integral from 1 to 3 of 6x squared minus 2dx. And I get 24, which is the same answer that I got before. Okay, the only other thing that we have to think about a little bit while we're doing these problems is what would the units be for this? So let me write you another example that uses units. Okay, so a function's velocity is measured by v of t equals 3 sine t. Okay, and let's say velocity is measured in meters per second. Okay, and I want to know what is the average velocity what's the average velocity on 0, let's say 0 to pi seconds. Okay, so they want the average velocity, and I already have the velocity function. So whenever what we're looking for the average of matches the function that we have, that's just an average value of a function question. Okay, so I'm going to set this thing up as, okay, I'm looking for average value. 0 is my a, pi is my b. I'm going to do the integral, I'm going to do 1 over b minus a, so 1 over pi minus 0, times the integral from 0 to pi of 3 sine t dt. So we should be able to calculate this thing. And what I want you to think about while you're doing this is, what should my unit be? Again, I'm looking for average velocity. So my answer should be a velocity like unit, right? Which in this case would be meters per second. Whenever we do the average value of a function formula, our unit comes out to the exact same unit that our function was before. Now, if I just did, right, if I cover up that 1 over pi, if I just did the integral of velocity, my unit should be meters. But again, this 1 over pi, that is a unit of 1 over seconds. So we're doing meters times 1 over second, which gives us back to meters per second. So the average value, going back here, the unit here is always the same unit of f. So we end up not changing units from what our original function was. Okay, that's kind of a shortcut. Let's go ahead and solve this problem, and I want to talk about using one of my integral rules to solve this. One of the rules that I talked about in the video on whatever day that was, I think it was Wednesday, is if I have a constant times a function, I can pull that out front. Right? I can just throw it out front. So this is the same as 1 over pi times 3 integral 0 to pi of sine of t dt. Right? Then I can combine these two to be 3 over pi. You don't have to do that. You can leave the 3 in there, and then the antiderivative of 3 sine t would be negative 3 cos t. Or you can pull that 3 out front. Either way, as long as you don't lose track of it, it should give you the same answer. Okay, so here's what I have. 3 over pi. I'm going to execute the antiderivative. The antiderivative of sine t would be negative cos t. Oops, negative cos t. I'm getting this from 0 to pi. And again, I can't lose track of this 3 over pi. Or if you kept the 3 inside of the integral, you can't lose track of that 1 over pi. I want you to get in the habit of writing it every time. Now you might say, Mr. Hartz, I'm never going to make that mistake. Well, pretty much everyone I've ever taught, and myself, we've always made that mistake. So don't lose track of it. Get in the habit of writing it down each time. So I have that 3 over pi. Now I'm going to plug in, I'm going to evaluate negative cosine of pi minus negative cosine of 0. Be careful here, this minus minus becomes a plus. So this equals, I'm going to write my 3 over pi so I don't forget about it. Cosine of pi is negative 1, so opposite cosine of pi would be positive 1. This becomes plus, cosine of 0 is 1. So I get 3 over pi times 2, so I get 6 over pi. But I have to consider the units here. Since I was doing the average value of velocity, it should be in velocity units, which is meters. That's it for today. We'll take a look at this tomorrow and begin our review process towards the big test. Talk to you guys later. 2 chains. Bye.